Hello, we're Team 48. This is our project, Data Exploration and Classification of News Article Reliability, a deep learning study. Ever since the onset of the COVID-19, the world has faced an infodemic where misinformation is being spread around the world at an alarming rate. The main cause of this infodemic is due to increased traffic to social media sites, which makes false information spread more rapidly. The widespread information propagation has led to active resistance against public health orders such as mask wearing and vaccine use, which is hindering our battle against COVID-19. To combat the infodemic, news organizations and social media companies have implemented measures to flag and delete misinformation, but the rate of manual detection is not fast enough to compete with the rapid spread of misinformation. Thus, we need a faster and more accurate method to detect it. Our main objective is to create a deep learning model to predict news article reliability using sentiment, engagement, and text. We will also conduct data exploration of the various characteristics of the news articles to find features to input into our deep learning model. We also want to explore potential traditional and deep learning models. We will now move on to the methodology. Shown in this figure is the general workflow of the project. We focused on an online data set called Recovery, which had 2,029 articles from a wide variety of news sources from January to March 2020 relating to COVID news. The articles were manually annotated as either unreliable or reliable. Additionally, there are over 100,000 tweets that are related to the articles. We also supplemented the data set with news articles found using a web scraping tool. These news articles were collected from reliable sites such as Healthline and unreliable sources such as deleted web archives. To determine sentiment of a news article, the data was passed through an open source tool called Vader, and the proportion of negative, positive, and neutral sentiment was recorded. Engagement analysis was determined by the responses and tweets associated with each article. Additionally, the tweet metadata, such as retweet count, likes count, and posting time, was included. For text analysis, the most common words from reliable articles and unreliable articles were determined. Additionally, more abstract elements of a text were extracted using Empath, which is a neural network-based lexicon. Important lexical categories, which are prominent in reliable or unreliable articles, are then analyzed. The
raw text data was then tokenized into a sequence of numbers before passing through a pre-trained glove word embedding layer. A series of machine learning algorithms were trained on our data to classify news article reliability. Each of the models shown on this slide were evaluated with 5-fold cross-validation with optimized hyperparameters using grid search. Lastly, a multi-input model was created, which takes the most important features from sentiment, engagement, and text analysis as input. This model was evaluated on the withheld testing set as well as the external web scrape news articles. We'll now move on to our results. In figures 1, 2, and 3, we said that reliable articles have higher means of average tweets, retweets, and likes. Additionally, figure 4 shows that unreliable articles have a higher proportion of tweets within a small time frame, meaning unreliable news may spread faster. In this figure, reliable articles, on average, are shown to have higher proportions of neutral sentiment, while unreliable articles have higher proportions of positive sentiment. As such, the data sentiment scores are inputted into the final deep learning model. Word clouds were generated for the 2 reliability classes. We noted several interesting patterns, such as the high proportion of political words in unreliable articles and more neutral words in reliable articles. Additionally, 128 empath lexical categories were found to be different in average proportion. This suggests that there are differences in major themes for reliable versus unreliable articles. And as such, the empath categories are also inputted into the final deep learning model. We tested a variety of traditional machine learning algorithms. Their performances are indicated in the OX scores, accuracy, precision, and specificity. NB and LR performed best at 67% accuracy. We also tested several deep learning methods, which are commonly used in literature for natural language processing tasks. While they all have relatively high performances, CNN performed best at 92% accuracy. Additionally, a multi-input model was developed named DeepRelie with a 93% accuracy. This new model uses both CNN layers for the text as well as dense layers for the features for sentiment and empath. The model architecture is shown in the following slide. In this slide, we see 2 confusion matrices for the evaluation of DeepRelie. One for the withheld testing set of recovery, while the other is on external web scrape data of 20 news articles split into sentences. The matrices show that DeepReli is very accurate in the testing set at 92% accuracy and also fairly accurate in the external data set at 80%.
Now let's get into the discussion of our findings. We identified a number of features which differ between reliable and unreliable news articles, such as their text and sentiment, which, in combination with the article body text, was used to build a deep learning model with a 93% accuracy in reliability classification. Unreliable articles surrounding COVID-19 were found to be much more sensationalizing than their reliable counterparts. This naturally creates an engaging topic to interact with on social media. Many researchers have inquired into what leads an individual to share misinformation. Recent findings suggest that concept of self-presentation on social media are a key component. That is to say, people interested in fitting in are more likely to share articles that have been circulated already. The other side of the fit-in attribute, however, was that individuals were willing to omit data that would disagree with the shared beliefs of their social circles. Additionally, individuals that valued uniqueness and wanted to stand out were found to be much more susceptible to sharing unreliable information. For sentiment characterization, we found that negative sentiments were found nearly equally in reliable and unreliable sources. More interestingly, however, negative sentiment articles constitute the highest proportion of unreliable articles. One such explanation is that the political undertones that dramatize the effects were found to be quite common. Reliable articles are found to have a higher proportion of neutral sentiment. This neutrality has been associated with impartiality in discussing the subject matter. This includes intentionally communicating the dangers of COVID-19 without creating panic. The word said was found to be the most frequently occurring word in reliable sources. We speculate that this is due to direct quotation of authority figures and their comments on COVID-19. Unreliable sources were found to be much more politically charged and contain words like country, government, and Trump. Articles with these underlying tones were found to be focused with propagating a specific political narrative rather than communicating scientific information. Now we would like to talk about the strengths and limitations.
In this section, I'm going to briefly outline the strengths as well as improvements in our model. In terms of strength, our paper has identified significant trends within Twitter data and the related news articles which justify their addition into the deep learning model. These features can also be expanded on by future researchers. Also, we have incorporated news articles into our model instead of Twitter post characteristics. Because news articles are written professionally, the sentences, structures, and word usages are more standardized in comparison to Twitter posts, which can contain jargon by the user. Another strength is the use of pre-built algorithms like GloVe for word embedding and Vader for sentiment analysis, with both tools recognized as high-performing algorithms in the machine learning field. In terms of improvements, we have a class imbalance between the 1,200 reliable and 500 unreliable algorithms, which might decrease the accuracy. Hence, a future improvement would be gathering more data to balance the classes. Lastly, a limitation of a model is that the model is specific to the dataset, and another type of model architecture might be better suited for reliability classification in other texts, such as books or scientific articles. Thus, while our solution has a strong classification accuracy in our dataset, it might be lower for other data. Because our model is able to boast a 93% accuracy, it is a valuable tool that can be advertised to the public. In our final model, we did not choose to include engagement as it was difficult to always have access to Twitter data, and we wanted a model that could be extended to a greater range of articles. Currently, the most prominent fact-checking methods that exist are mostly manual fact-checking, but these methods are insufficient to keep up with the rapid spread of misinformation. Thus, we need a more efficient method to better target misinformation. Our first step is a proof of concept implementation of DeepReli that is available to the public. We plan to extend this feature to mobile platforms or even a browser extension that can scan articles in real time. Furthermore, a dedicated server and new website design would allow for greater flexibility in how DeepReli is implemented. Ultimately, our final goal for the website is to see its use in both industry and individual use, normalizing machine learning algorithms to enhance fact-checking tools. Our plans to improve the DeepReli model itself will come as a result of using a wider range of data as well as adding more features to support improved pattern recognition. In summary, we developed a deep learning model called DeepReli that can distinguish between reliable and unreliable articles with an accuracy of 92%. We also conducted an exploratory analysis of the engagement, sentiment, and text. DeepReli gives immediate feedback on the predicted reliability of the text, which we hope will support decision-making when reading news online. Thank you everyone for listening to our presentation. Please check out our DeepReli site at the link shown in the slides.